Okay.
Okay. Thank you again to the team here with WIT at University of Albuquerque. I'm so excited to be able to finally do this. We were supposed to do this in November, but I ended up being called on a board meeting to Tahoe, Lake Tahoe in November, which ended up being a very snowy trip. So I'm happy to be here at the dawn of spring. And thank you for all of you who are here today and instead of enjoying the outdoors, because I'm in just outside of Santa Fe and we're having a beautiful day. We are going to talk about application security and software security. It is an extremely important topic at the moment. We have had some pretty bad cyber attacks and hacks due to many things, but there is a big concern about how we construct software and what we put into it. And oftentimes that is called supply chain. I know it's a term that gets used all the time, but it is definitely a software supply chain issue. And because of this, this market is expected to really, really grow. It's probably going to grow at an average rate of about 22% through 2027. It's a $27 billion market. And if you are currently in software and you're looking at focusing in any particular area, I would say that application security, DevSecOps, supply chain management is a very, very good place to get started. But first, let me tell you a little bit about myself. When I was asked to do this, they asked if I would give a bit of a journey, how I've gotten to where I am. I can tell you that I'm always an optimist, and I always have, I believe that anything is possible, and that sort of has driven my career over the course of the years. I've been doing this for about 25 years. I began as a programmer. I was actually a mainframe programmer and didn't want to stay on the mainframe, and did mainframe coding for about, 8 months. And then once I started doing I took a course on C programming, and I was living in New York, and there was a big need for C programmers and OS2 developers. And I decided to jump on that bandwagon because nobody else was. And I started consulting. I was a consultant in New York to Wall Street firms for about 5 years. I eventually found myself working at Discover Financial outside of Chicago. And my partner and I, who I met in Chicago, started working on solving the software compile process, the compiling and linking of artifacts together to create binaries. And how do you track what you put in your artifact? How do you know that what you are sending out to your end users actually only contains what it needs to contain? And we called that a build audit report. We built a company around that, a company called OpenMake Software. And we went on a kind of an odyssey. To this day, our product Meister is still running in some very large organizations to manage their builds. But it dealt with what we like to call monolithic compiles. And we are now seeing a change into cloud native, where instead of building one big giant binary, you build smaller components that are built in container images. And we saw that there was a need for tracking what container images your end users consume that make up what I like to call your logical application. So we started a company called DeployHub in 2018, and it is the journey that I'm on today. But I did get started as a developer. It's a really good place to start in the industry. But if you're looking at where a good place to focus, I would really look at the application security market, DevOps and DevSecOps. Along this journey, I've been involved in quite a few open source communities. I actually helped found the Eclipse Foundation. I was on their governing board for about 5 years. I used to say I was their token woman because there was a room full of men, lots of testosterone. Let me just put it that way. And I sometimes was the mom that said, "Okay, you guys, you're getting out of control. Let's get back to where we should be." I've also been involved in helping found the Linux Foundation Continuous Delivery Foundation. So for those of you who don't know, the Linux Foundation is a consortium of open source projects. They have, I don't know how many different foundations that the Linux Foundation governs, but the Linux Foundation provides a governing structure for these sub-foundations. And within the sub-foundations, there are open source projects. Two of the sub-foundations that I'm involved in is the Open Source Security Foundation, the OpenSSF. I served on their governing board for a year, and I served on the governing board of the Continuous Delivery Foundation, the CDF, for about 2 years. And I currently serve on their Technology Oversight Committee. Now, if you've never thought about getting involved in open source, it's an amazing way to beef up your skills and your resume, and it's a really good way to network. When I first got out of college, networking meant you went to end user meetups and you hung out at end user meetups on monthly basis. Maybe Microsoft was holding end user meetups, and that was a way to network. In today's model, open source projects are the best way to network because you end up meeting people from big companies, IBM, Google, Netflix, all in the same room, and everybody working towards a similar end goal. So check out the Linux Foundation for more information about the different projects that they run and the ways you can get involved. I'm involved in the CD Foundation and the OpenSSF. So along this journey, because of my interest in open source and my love of it, we contributed about 80% of our DeployHub, the company I'm currently working on. We contributed about 80% of our code base to the Linux Foundation, and we got accepted as an incubating project under the Continuous Delivery Foundation. And that product is called Ortelius. It has roots in New Mexico, so we used an alien as its image. And we talk a lot about our dream of being able to build an amazing open source platform from contributors from New Mexico. But to be quite honest, the only two contributors from New Mexico are Steve Taylor and myself. I would love to have more people from the university systems around New Mexico to be involved in open source. But open source is not often taught as a way to increase your skills and increase your networking within the US university systems. It's super popular in India. We have several university students from India that are contributors and are very active. But the US university system, I don't think has seen the benefits of and what students can learn from the open source communities, and in particular women. We do not see a lot of women in open source. I forgot to add this, but I'm also the host of TechStrong TV's their TechStrong Women program. So 2 times a month, I get to interview amazing women who just, I would say amazing technologists who just happen to be women. And I hear their journey, and we just actually sit down and have an amazing talk. So you can check out TechStrong TV and look for TechStrong TV Women, and you'll see our channel. I live in the Cerrillos Madrid area. It's an odd place to start an open source project that we're trying to fill a global space. And I like to hang with big horses, and I have dogs. So when I'm not doing something for the OpenSSF or the CDF or Ortelius or DeployHub or OpenMake, I spend time with my dogs and horses. So let's get back into the matter at hand. Software security is very complex. There are so many different ways for hackers to attack software. There are many, many doors that they can open. It is a, we will get better at protecting software. Will we be ever 100%? I don't know. We could be. It would be great if we could be, but there's a lot of work to do to even get to 80%. That would be amazing. Over the course of the last few years, malicious supply chain attacks has increased by 742%. And I talk about supply chain, I'm talking about the code, open source packages in particular, that you may use when you write code. Now, boards across, enterprise organizations, large organizations, the Mobile Oils and the Bank of America, they really consider cybersecurity a core business risk. So they actually calculate that in their models, and 88% of them see it that way. Now, 65 to 80% of companies want to have more visibility into application security. What the heck are we consuming? If you were instead of a software company, if you were making peanut butter, you would have to put the ingredients of the peanut butter on your jar. It's required by the FDA. But in software, that has not been done. So there is no visibility into what you're consuming when you take software from somebody else. You download something on your local machine, you don't know what's in it. You're just hoping that the company you downloaded it from is doing their due diligence to make sure it's secure. Well, it's not always the case. Software is a busy process, and testing and security sometimes is forgotten or done at the last minute. And this is part of our problem. This problem then creates what I like to call supply chain toil. IT teams really do struggle to understand a software application supply chain. Now, in a monolith world where we were building one big binary, it was hard enough. But now we've taken that binary and we've decoupled it into microservices. This makes it even more complex because the dependency graph becomes massive. You already had a huge dependency graph in terms of the open source that you were using. Now you have that times 100 if you have 100 microservices. And at a minimum, application teams are being asked to provide a list of all the dependencies they use to create the object, even though they may have no easy way to find them. They need to tell their end users what licenses those open source packages that they've consumed, are they under a license that they are allowed to use that software? They also want to know who created it and the ownership of software. So ownership and license obligation tends to be a big topic. And most important, what are those known vulnerabilities for all included artifacts so they could be quickly remediated? And these are called CVEs, common vulnerabilities and exposures. So if I take my peanut butter example, if there was something wrong with one of the oils that was used in the peanut butter, and there was a vulnerability to that, it would be taken off the market. We don't have a similar way to do that. And this happened in an open source package called Log4j. I like to say that Log4j created a massive security awakening. It was a wake-up call. So Log4j was used in literally thousands of pieces of code called Log4j that was compiled into thousands of binaries. In just a very short period of time, just semantics intrusion detection system blocked more than 93 million Log4j related exploitation attempts across more than 270,000 unique machines. That's just semantic making that, tracking that data. Literally millions of developers used Log4j to perform basic logging functions. And what the problem was there was a backdoor exit in Log4j that said, hey, if you need to get out to the operating system to do something, here you go. And when that was found, it created a massive problem for a lot of companies. And IT teams quickly learned that they did not really understand their basic supply chain intelligence. It just was non-existent. It was extremely hard for developers to report to upper management where and what version of Log4j that they were using. And this was the question everybody was asking: where is it? Where do we need to replace it? Because of course, the poor guy who has supported Log4j for the last 20 years, he fixed it, got the fix out, but that means everybody had to recompile and redeploy all of that software so it was using the correct version. And some versions of Log4j didn't have the problem. So if you knew clearly what version of Log4j you were using during that attack, you knew what your exposure was. And you could also determine, if you had enough intelligence, you could have said, we've been exposed for the last year and a half. But this type of information wasn't available. And it's because of our lack of due diligence around tracking the open source packages and making sure those open source packages are secure. So Log4j didn't get just the attention of a lot of developers. The Biden administration took note too, because believe me, the government used Log4j as well. And can you imagine in the government with all of these secure systems and military, an exposure like Log4j was offering to hackers, an easy way to get to the operating system, meant as soon as they were at the operating system level, they could do anything they wanted. It was a vicious problem. So in 2021, the Biden administration said, you know what, we need to know your ingredients. You owe us that. If you are going to do work for the US government, you'd better know what versions of open source packages you're consuming. And we want to see it in what's called a software bill of material report, an SBOM. This mandate went into effect in September of 2021. It was announced in May, so it didn't give companies a whole lot of time to start generating SBOMs. But if you're going to do work for the federal government in any capacity in software, and you're delivering code to the federal government, you must provide a software bill of material to the government before that software is installed. And what they do is they're taking a look at those SBOMs and they're looking to see if there's vulnerabilities in your code and tracking those vulnerabilities over time. Because the darn thing about vulnerabilities is that today you might think that you are completely secure, and tomorrow somebody's going to find a vulnerability in a package that you use and you're going to realize you're not secure. It is a moving target. And the federal government is responding to it by asking, at minimum, that these software bill of material reports be delivered. So I had this awesome opportunity to get to go to a House committee hearing on open source. And they had some folks from the Department of Homeland Security and some other groups that attended this meeting. And it was through my work with the OpenSSF and being on their board. Before we went to that meeting, we sat down as a group and we looked at a mobilization plan, basically 10 different areas that we could focus on to help open source be safer. And some of these areas seem obvious: security education, educating developers about the problem of open source security and the tools that they should use in order to protect it. Risk assessments. The Linux Foundation with the OpenSSF now has something called a scorecard that you can score how safe your code is. Digital signatures. This speaks to provenance. Who created this particular object? And digital signatures can be used at different levels. Memory safety. This is something that there's a process called software composition analysis. And software composition analysis tools will scan your code and look for things like memory leaks and memory issues. Incident response. This is one of my pet peeves, incident response, because guess how people learned about Log4j? They learned about it because somebody started tweeting about it. A person in China saw it, played with it, and finally started telling everybody, hey, there's a problem with Log4j. And that is what created the fire, so to speak. But the problem was we had a fire, but we didn't have a fire department. We had no level of standard ways of responding to the incident. We just had a fire. And to this day, we still don't, at a federal government level or at the Linux Foundation level or any other level, have a way to say, I found a vulnerability. How do I report it? There are eventually ways to get it into the CVE databases. But if you're just a developer, you may not know how to report it. And it's not easy to understand how to respond when you find an incident. Again, better source code scanning. This has to do with software composition analysis tools, as well as code audits and data sharing. So there's tons of information and security risk around databases. And that's kind of the area that focuses. Then there's improved software supply chains. And if you ever understood the DevOps process, that category really focuses on the life cycle and how to improve what you're bringing into your organization. And in order to do that, the key to all of this is truly SBOMs. And one of those core pillars is to define what supply chain tools do we need to use in order for SBOMs to be used everywhere. Again, I have issues with many of these things, and one of them in SBOMs everywhere is it's great to generate a SBOM, but we also need to consume the data. If you generate a SBOM, it's a checkbox. You leave it out on a build directory, and it may not have a whole lot of value there. There's two big projects that the OpenSSF started. One's called Alpha Omega, and the other's called SIGSTOR. Alpha Omega is intended to support open source projects. And the alpha side of the Alpha Omega project is going to identify some of the most critical open source projects, Linux, for example, Kubernetes, for example, and improve their security posture. The Omega side of the Alpha Omega project will identify 10,000 widely deployed OSS projects and apply their security analysis and scoring and remediation guidelines for those communities. SIGSTOR is all about signing. They have, I think, 3 or 4 different signing tools, and these tools are used to identify or as one single process for a holistic approach to open source security signing. And Jim Zimlin, who is the executive director of Linux Foundation, he stated that, I'm just going to read it because it's interesting. He says, with ripples felt by the global technology sector at large was the Biden administration's executive order on improving the nation's cybersecurity. This bellwether indicator puts software bill of materials at the forefront of software procurement practices. And SBOMs will play an essential role in building more trust and transparency in how all software is created, distributed, and consumed throughout the supply chain. And if you're curious, you can search for software bill of material and cybersecurity readiness. It's got a lot of little curious tidbits in there about how many companies actually use an SBOM and how many companies believe that they need to start using them in the future. I'm not going to get too deep into what an SBOM is, but it's important to understand why an SBOM is needed. So if we kind of look at the doc this little frog is holding, we can see some things that have been underlined just so you can understand what it's collecting. And this SBOM is using a format called SPDX, which comes out of the Linux Foundation. There's another format called Cyclone DX, which comes out of a company called Encore. And these files are stored in JSON or YAML files, and they live side by side with the article that was built, the artifact that was built. And this one, we can see who the creator is. And we can also see some of the packages. So you're going to get a list of these packages. And this is where sort of the gore of SBOMs come across, because it's going to give you a list of all of your packages. Now, knowing what your packages is means that you can now find out what that package's vulnerability is. So SBOMs are the core to understanding what's included in your artifact and if it has a vulnerability. So just some numbers to understand. 98% of the companies use open source. If you think about basic operating system level open source, like the Linux Foundation and Linux, that includes a whole lot of companies. That's why that number is so high. 88% of the companies claim they're going to implement SBOMs, either they did last year or they want to have it done by 2023. It's an ambitious goal. 74% want to consume SBOM data. So they're saying here that we need more log visibility. It was in that earlier that slide. And 66% say they will increase the SBOM usage once they start generating them. But only 47% of companies used SBOMs in the beginning of 2022. So we're behind the 8 ball, so to speak. Now, I would be remiss not to go over other things that organizations may not be looking at, like the Linux Foundation. And I'm not sure completely of the level of tech that this group has, but I'm just going to say that in cloud native, it becomes more complicated to manage pieces and parts. And in order to get an SBOM, you have to know the pieces and parts. So they go together. Microservices add a risk factor because oftentimes organizations cannot track who's consuming a particular microservice. So let's say, for example, you create a microservice that is a standard login routine. And that login routine is then borrowed by many, many different application teams because they don't want to rewrite the login routine. They just want to use it. And that login routine may call some other logging routines that says when somebody tries to log in more than 3 times, we're going to block them. It may send some kind of a red flag to say this account may have been compromised. So there could be that one login routine could have other microservices that it sends data to. So what happens is you build a massive Death Star of dependencies of all these microservices, and tracking who uses them, tracking and organizing them become extremely difficult. Now, every microservice uses open source. So you have microservices now that are consuming open source packages. So let's say if we took the Log4j example, if we had a ton of Log4j or microservices that are using Log4j, we would have had to rebuild every single microservice and correct that. Maybe Log4j should be a microservice, right? I hope that happens. That would be really a good thing. And then the microservice reuse maturity, the level of service sharing across teams. How critical is this one service? So while we have a set of standard pillars that companies like the Linux Foundation and OpenSSF are looking at, we also need to consider the other details that organizations face that may not just be about trying to secure open source packages. We have outer source, open source, and we have inner source, and we have to track the inner source as well and the inner source dependencies. So as enterprises start building these highly decoupled microservice cloud native platforms, it's critical that they be able to easily understand what their Death Star looks like. And most importantly, we need to update the automation and the security around the software lifecycle, or what's often called the DevOps pipeline. In this image, I basically give five phases of where security needs to be added. Initially, if we look to see this first step here, code and pre-build here, is all about source code scanning, those SCA tools. Now, source code scanning is also shared by repo scanning. So if you could actually use some of these tools to scan your entire GitHub repo of source code to see if there's any issues. But the first line of defense would be for developers to be able to scan the code that they just checked in. The second level, which is really one of the most complex levels and has the most, I would say it's the most vulnerable, is the build. How things are getting added into a binary and the generation of the SBOM. So there's new ways of generating SBOMs. At the point in time that you create your SBOM image, you can use tools like AppCo and Docker BuildX to actually create an image SBOM. There's also ways that we can improve builds by making sure we're not doing it on a PC underneath your desk, like I used to do when I was a developer. That seemed quite fine to me, just to run a build locally and then share the executables. But now companies are using what we call hosted build systems to do that. And then that thing we talked about, signing. Signing, it tells us who created it, the provenance, and who changed it, the attribution. So tools like SigStore and Notary do that. And then there's some really cool tools out there that does what I like to call package verification. That does a build across a decentralized consensus network. So instead of building on one machine, you build across multiple nodes and you make sure that they all look exactly alike. And why would you do that? You do that to make sure you didn't have a nefarious package dropped into a build directory of your build machine sitting underneath your desk, and bingo, you have a bad situation because you have code that you didn't want in there, and that code could be something that would allow somebody to exit out and get out to the operating system. This has happened. And then there's post-build. So post-build, if you're not generating an SBOM when you compile or you build your container image, then you need to kind of take a detour and you need to run that post-build SBOM. Tools like SIFT with the SPDX and Microsoft SBOM is intended for that use. And then at the end there is probably one of the most important steps in my mind, is to publish that information. You publish it in artifact registries like Artifact Hub or Quay or Maven Central. And then you begin gathering the evidence. And that's what Ortelius does. And that's the project that I'm currently working on. So when you have these big decoupled platforms, architectures with microservices, what ends up happening is the security and DevOps data ends up being trapped in these containers and pipelines. So every microservice has an SBOM. If every microservice has an SBOM, how the heck do you turn over an application SBOM to the federal government? That is the problem with cloud native and decoupled environments. Oftentimes, we don't even know what the application looks like. We don't know what it's using. And observability tools running in production try to say, this is the transactions that are happening across these microservices. But sometimes it's hard to say, this is the logical application and this is the logical application's SBOM. And that's what the Ortelius project is working on. And that's what DeployHub is. So DeployHub and Ortelius provides an organization's security profile by pulling all of this data up from the microservices, where they're deployed, where their SBOMs are, what their impact is, and displaying it at an organizational level. So now if you needed to find the answer to something as simple as log4j, we can do that because it continuously captures this information being pulled across the DevOps pipeline like Jenkins. And as Jenkins runs, It tells everything about, it pulls all that information from everything that Jenkins is calling. We grab that information and we put it in one big data lake so that we can see it and act upon it. So let me just finish here with telling you my journey in starting a new company. In case any of you are brave enough to do so, I would love to hear more women are looking for funding to start new companies. DeployHub was launched with its first the minimal value product here was completed back in May of 2019. We launched it in July of 2019. Unisys was our first customer. We began looking at the open source puzzle because it's something I'd always wanted to do, is have an open source project. And we didn't go out and look for funding at the time. So we wanted to figure out a way to get more help in building this. And we looked to the Linux Foundation to get that done. And Ortelius was accepted in December of 2019. So it's been incubating for about 2 years. I would say that our biggest challenge right now is early adopters. One of our early adopters is the New Mexico Department of Workforce Solutions. They use DeployHub, as well as a very large bank in Latin America called Banorte, and the Texas Attorney General's Office. They use it as well. So it doesn't surprise me that we have government organizations starting to look at DeployHub and Ortelius, because it tracks that critical data about all your security and your DevOps evidence in one place. Our go-to-market model is, first, we're open source. That's where we get acceptance in the community. We've built quite an interesting open source community. We have about 250 people in our Google group, meaning they get our emails and they watch what we're doing. We have about 700 LinkedIn followers in Ortelius. We've reached a critical point here where we have 264 GitHub stars and about 115 GitHub forks, which means there's people who are forking the code and starting to work on it. And we did about 203 total pull requests in 2022. On the DeployHub side, we have an on-premise pro version that people can download and install and use. And we also have a SaaS version. So we're building a SaaS model. And in terms of investor interest, a SaaS model is extremely attractive to them because they are cash cows. If you can get it done, it's a lot of work, but if you're successful, it's a windfall. And on that, I will leave it to any kind of questions. This is where you can find me. If anybody wants to chat, reach out to me at tracy@deployhub.com. I'm happy to talk to anybody who's more interested. And especially if you're interested in learning about how to join an open source project, we would love to have some women in this open source project. We do have a lot of fun. We do crazy fun things through the year. We create ways to contribute. And we have some really awesome guys who are great mentors who can help you learn to do any kind of coding and learn any aspect of this process. So I would encourage you to reach out to me and say, hey, how do I get involved? Because it's a really good way to improve your resume and your skills. And on that, I will just open it up for questions. Let me find wait, here it is. Wait, where'd it go? I'm looking for the chat box. Oops. There, chat. So there's a chat box here. You can ask me a question in chat. Don't be shy. We're a small group here. Or Jenny, if you want to, you can take everybody off of mute and we can just chat openly.
Sure. I have to say I am not a software person. I am a systems person, but your talk is very interesting.
Good.
Dee Dee, probably a good person to. Do you have any question, Dee Dee? I think you're a software developer.
No, I'm not software developer.
Oh, okay.
I'm part of IT applications, but I'm more of the I'm helping with the DevOps processes that we would like to implement. So,
well, that one screen, and I'm happy to share this slide deck with Jenny, and she can pass it off. But this screen up here, for somebody who's doing DevOps, this is a good place to follow. And if you go to the DeployHub site, there is a white paper that you can download that covers this.
thank you. This is very helpful. The thing is that we still have challenge of choosing the right platform, and even before I came here, we had discussion about the Kubernetes choice that we would like to use. And I read that basically the Red Hat OpenShift is one of, takes awards. I'm wondering, what is your advice? Because there is conversation of using Linux containers and because anyhow,
so I think
conversations.
Personally, I am a huge fan of microservices. Let me give you an example. I'll tell you the day my head exploded because I learned about microservices. There's a company in Santa Fe called OpenEye. It has since sold for a bunch of money. But OpenEye, what they did was they took the molecular structure of chemicals and created a way to do pattern matching on them. So if you were a pharmaceutical company and they had about 10 primary pharmaceutical companies that they were serving, and they were serving them as if they were part of their development team initially, and you needed to do research on a particular compound that you were going to be including, and you wanted to know if you could get a patent on it. What normally you would have had to done is you would have had to drawn it up, basically submitted it to the patent office, and 6 months later you'd get an answer. Well, the patent office has open source data on this. And what they did was they started bringing in the images and they would do pattern matching on it. Now, in a monolithic world and regular computers sitting around an office, you would not be able to do this, because what's required is the ability to spin up a lot of GPUs, graphical processing units, all at once in order to get the data and bring it back. And when I went to it was a software development meetup in Santa Fe, because I wanted to learn more about what they were doing in OpenEye. And he had a little counter in the top of his application. And they did a search on aspirin, on what the aspirin compound looked like. And he went from something like 100 GPUs to something like 1,500 GPUs in a matter of seconds and brought back that information instantly. Now, you can't do that with a monolith. You have to be able to spin up tiny little parts in order to take advantage of this new technology. So the problem is that we have to learn it. You can't just, when fools rush in, we make mistakes. And you really need to learn the technology and take a slow approach. But I would, at this point, never even consider writing a monolithic application in today's environment. Never would even consider it. I would take the time to learn the new platforms and understand how to build out use a domain-driven design to build out your microservices. And the other thing that it does is it's more democratic. Instead of having one application written in one language, a microservice can be written in any language you want. So you can bring in people with different skill levels to help you build your software. So that's my suggestion, is I would really be looking at learning Kubernetes, understanding it, and understanding the architecture and what it can, the value it has, the potential to bring back to you, and to be able to spin up these GPUs to service people is important. During COVID, the Department of Workforce Solutions, they were swamped. They were literally swamped because everybody was filing for unemployment. And I was listening to NPR on the way home one day, and they talked about how one of the states, not ours, could not process any more unemployment claims because they needed to get a purchase order for more PCs. You do not want that to be the story about your company. I sounded so old-fashioned to me. I was horrified by it. So those are my thoughts. Thank you for the question.
Thank you.
I do have a question. It finally dawned on me. When you talk about using microservice, are you talking about the one over in Azure?
Yes. So the Azure is a cloud service that's based on Kubernetes. Mm-hmm. And what most people are doing right now is they take their monolithic application and they put the whole thing in a container. And then you can spin up as many versions of those containers as you need. Instead of having to go buy more PCs, you can instead spin up another container. And platforms like AWS, Google Cloud, and Azure are Kubernetes environments that you can use to deploy your software in containers.
Okay. And my next question is about back to the SBOM. So SBOM, going back to your peanut butter, jar of peanut butter analogy, SBOM is basically the ingredients, right, that you want to display. So when you consume the application, you know what you are consuming.
Correct.
Is okay.
That is exactly what an SBOM is. It's a list of ingredients. And the software industry has never been required to provide that list of ingredients until Log4j broke us. And that's when the government stepped in and said, we have to have your list of ingredients. Now, the list of ingredients goes beyond just the list of ingredients. It also says what licenses, who created it, and it tells us we can now go look at a CVE database to see for that particular package, that list of in that list of ingredients, what the vulnerabilities are. So it's a critical part of the security puzzle.
Okay, I'm trying to unmute Didi. I think Didi has a question. Can you unmute yourself, Didi?
Yes, I think Janelyn has a question. She posted it in the chat.
Are there any risk or consideration? Okay, so she asked, are there any risk or considerations around the security of the SBOM itself? I'm thinking this could be, oh, I love that question so very much because it's something that I have brought up so many times. Okay, so for example, when you generate an SBOM, it sits in a text file, as I showed you, in a directory. If somebody wanted to, they could say, I want to improve my score. I'm going to just delete out of the SBOM some of these packages that I don't want anybody to know I'm using. Simply done. Would somebody do that? I don't know. But yes, there is. Now, the Ortelius project got a grant. We got a $75,000 grant to create an immutable SBOM blockchain to solve that exact problem. So for example, as soon as the SBOM gets created in the pipeline, which would be right here or right here, Ortelius pulls it in and grabs it so nobody can modify it and creates a block in a blockchain that shows its original, what it originally looked like. Now, if we do another build in an hour, we create another SBOM for that object, right? Because every time you do a build, you create an SBOM. That new build may have new packages. What we're going to show is the difference between those SBOMs over a course of time. And it's our way of solving that particular problem. So most excellent question. Any other great questions like that? I love that you jumped to that level because it is truly a kind of a gap. And there's so many gaps in this stuff. We're just really now getting started. Log4j happened in December of 2021. And here we're just at the end of December 2022, right? We're still in the winter. We're still in that winter. So we're just now getting started with these discussions, and SBOMs is going to be a core. Now, I didn't talk about, I said there were 5 phases and I only have 4 up here, but there's another part of this, which kind of goes to your question. And that is the pipeline audit itself. How do you know if somebody changed one of these actions in your pipeline itself? So there are tools that do pipeline audit. There's not many. Google created something called Tecton, which is a DevOps pipeline CD kind of orchestration tool that has also something called Tecton chains. And chains can show when something changed. So that question speaks to 2 different areas. What do you do with these text files that are so critical, and how do you protect them? And how do you make sure somebody didn't update the pipeline to take image scanning completely out? Any other questions? And if you have questions about, your current journey, where you're at in your career, any of those kinds of discussions, if you want to help and you're looking for a mentor, be sure just give me a holler at Tracy@DeployHub.com. So happy to help any of you. Devin, you're very welcome. It was a pleasure being here. And Adele, and to all of you. It's a pleasure being here, and I wish all of you the best of luck and success in your careers. And check me out on Tech Strong Women. I've been interviewing some really cool women. One woman, her name is Jamie Thomas, and she's from IBM. And she was really fascinating to hear. She talked about cybersecurity, and she said that some economists that they're working at IBM that are also working for the US government have indicated that if China was to blockade Taiwan, they wouldn't have to attack them, just blockade them. It would bring down the US economy, and because of the chip manufacturing. It's why the chip and science bill has been so incredibly important. I don't know what anybody's political affiliation is, but the chip and science bill is critical to our safety, because as we saw during COVID, it was hard to get parts. The auto industry depends on chips, and this is cybersecurity on steroids, right? All China has to do is blockade Taiwan, and we can't make cars. So hers is very interesting. It's going to be, I don't know when it's going to go live. We just did it, so it's probably going to be 2 weeks. So look for Jamie Thomas on Tech Strong Women. It's a very good one. Yeah, Devin, it is really scary stuff. I thought the same thing.
I think they've already decided to have chip manufacturing.
Yes, that's what the chip and science bill is.
Mm-hmm.
But unfortunately, some people, one of the requirements for doing business, they're going to give them, I don't know, $50 billion to build a chip manufacturing plant. But there are some who don't like the bill because, as part of the bill, those manufacturers are required to pay pay a decent wage and to provide childcare services. So, you know, there's a discussion about, oh, it's become a social package. Well, you're getting to get $50 billion. It's a corporate welfare package too. Everybody wins, in my opinion.
Yeah.
But we'll see where it goes. And I believe that there's 3 chip manufacturers being built, or 3 plants being built, one in Arizona, one in Texas, and one in Ohio. So it is happening. But it's going to take 10 years or 7 to 10 years to get them off the ground.
Yeah, it takes a while. I don't know how Intel has a place in China too. So,
well, we won't be getting them from there if there's a blockade against Taiwan.
They moved. Yeah, Taiwan is the main one. Just that's why we have to defend Taiwan.
The Japanese government just invested $59 billion to build a chip manufacturing plant in Japan.
Japan, yeah, I'm surprised. Japan used to be a technology front. I don't know what happened to them. So that's a question I asked Jamie, and she said that the technology around making chips is not simple. And it's a focus that the Chinese had, and a lot of the equipment to actually make these chips come out of China, and it's their proprietary technology. So that's a problem, right? We're going to have to buy the equipment from China in order to build our own plants. They have us. So.
Well, we're going to get it there with more. I'm sure the Chinese will be happy to sell those. It's going to be a big dollar, I'm sure. The equipment, and there are U.S. companies now who are looking at creating patents for doing the same.
Oh, good. Germany I'm surprised Germany is not in that part of the technology, because they're very good with engineering of a lot of tech type of.
Yeah.
Equipment. So, okay. Anybody have any more question for Tracy? Okay. I'm going to close the recording, and then I'll send a link to everyone if they want to go back to this presentation. I think it's worthwhile. Yeah. There's a lot of information in this presentation. So,
Jenny, I will send this the slide deck to you.
Thank you.
I'll share. I have it in slides. I'll share it with you.
Okay. Thank you.
You're welcome.
Thank you, Tracy.
Yes. You're welcome. Thank you for the great questions, ladies. Appreciate it.
Okay. I will stop the recording.